Hello and welcome to lesson 10.2 from Pre-Algebra. This one is about area of triangles and trapezoids. If you remember last time we talked about the area of parallelograms. Parallelograms were four-sided figures that had two pairs of parallel sides. Today we're going to talk about areas of triangles specifically and also trapezoids. Alright, so before we go ahead and go any further, let's go ahead and do a little bit of a recap and let's make sure that you remember what is important. Alright, so here's a little recap for us just to kind of go over some important things. Whenever we talked about area, I always remind you guys that area is what? That's right, squarea. Area is squarea. If you did not know that, you were definitely not paying attention. All right, last lesson. We had a formula for area. Area is equal to what times what? You are correct if you said base times height. Base times height. Cool. And area was always in square units. What is the exponent that goes over every unit for area? You are correct if you answered 2. Inches squared, meters squared, in fact, feet squared. All right, so a little bit of review for you guys. This is an example of a parallelogram. You might be thinking, hey, that looks awful lot like a square. Well, a square is a parallelogram. It has 4 sides and 2 pairs of parallel sides. All right, so if I said that this has a base of 3 inches and a height of 3 inches, what would the area be? Well, if the area is equal to base times height, then it's going to equal to 3 inches times 3 inches. 3 times 3 equals 9, and inches times inches equals inches squared. So the area would be 9 inches squared. Cool? Alright, well this lesson we're going to talk about area, but specifically of triangles and trapezoids. Now, who can tell me how many sides does a triangle have? Very good, very good. It has 3 sides. Now, if I take this parallelogram, this square, a rectangle, any parallelogram, and I wanted to make this into 2 triangles, what I would do is I would just draw a straight line from one corner to the other, also called a diagonal. So if I went ahead and drew a straight line and cut this, all of a sudden I have 2 triangles. That's interesting. That's actually going to lead us into the formula that you guys need to write down. Let's go back one. Alright. I need you guys to go ahead and write this formula out. The area of a triangle is going to be base times height divided by 2. Right, and this is the big formula for today. All right. Now, where does this come from? How did I figure this out? How did I ever come up with this idea that the area of a triangle is base times height divided by 2? Well, if a parallelogram has an area of base times height, and a triangle is just half of a parallelogram, all I did was divide base times height divided by 2. And that's exactly what your book shows right here. It gives you 3 examples of 3 different parallelograms, all just kind of cut in half, cut in half, cut in half. And it didn't matter if it was a right parallelogram or a slanted parallelogram. In any case, the triangle is just going to be half of a parallelogram. So, for this reason, we have this formula. Now, again, just kind of recalling what I just told you, I prefer this form. base times height divided by 2, because this is a little bit more like what we use when we cross cancel, but this means the same exact thing. 1/2 times base times height. Let's go ahead and look at the first example. Find the area of this triangle. Okay, here we have the triangle from your example in your book, where we have a triangle that has a slant height of 5 centimeters on each side, an altitude height of 3 centimeters, and a base length of 8 centimeters. So let's go ahead and fill in our information. In order to figure out the area of this triangle, we just need to find the base and the height. And the base length, the area running along this bottom part, looks like it's going to be 8 centimeters. And the height is actually going to be this 3 centimeter line. Right? Why is this the height? Well, if you remember from last class, we talked about how the height is always going to be perpendicular to the base. So let's go ahead and plug these numbers in. The base is going to be 8 centimeters, and the height is going to be 3 centimeters. Can anything cross cancel? Yeah. In this case, the 8 and the 2 cross cancel, become a 4 and a 1. And all we have left over is 4 times 3, which is 12. Now, what unit should we use? Centimeters? No! You should be using centimeters squared. Why? Because, say it with me, area is square area. Hey, look, that's what we got, and that's what they got too. Alright, cool. Let's go ahead and look at standards check. Let's go ahead and do part B, because part B looks a little bit different. Part A looks pretty much the same thing like what we just did. Part B looks a little different, so let's go ahead and practice that one. Alright, so this is our example for part B. Here we have a triangle that has, well, 3 different sides, like most. We need to figure out what's the height and what's the base. Well, because these two are perpendicular to each other, it doesn't matter which one's the height and which one's the base, because I could easily just rotate this if I wanted to and say, well, one's the height, one's the base. You know, it doesn't really matter how I rotate this. Instead, what we're going to do is we're just going to go ahead and make a decision, and I'm going to say that, let's say that this is the base and this is the height. So in this case, well, we no longer have centimeters, we have meters. All right. So here we have a base of 5 meters and a height of 2 meters. We're going to go ahead and plug these in. 5 times 2. 2 and 2 cross cancel, and I end up with 5 meters squared, because area is square area. Okay, now let's switch gears for a little bit, and let's talk about a different type of problem. What would happen if I had 2 different shapes? So far we've talked about parallelograms in lesson 10.1, and this time we're talking about triangles. What would happen if we combine them together? What would happen if we had a shape something like this, where we had 2 different shapes kind of put together in one? And if I told you that this bottom rectangle had an area of 20 square meters, and the top triangle had an area of 8 square meters, how would we find the total combined area for this shape? Well, you might be thinking, gee, Mr. Lopez, shouldn't we just add them together? Yes! Yes, we would just add them together. So if I wanted to go ahead and add these together, I would go ahead and add 8 square meters plus 20 square meters, and I would get 28 square meters. Now, would our unit be square meters? Would it be meters to the 4th? Well, I beg of you to think of it this way. If we ever have to add money together, you wouldn't say $3 plus $4 is $7 squared. You would just keep them, as dollars. And when you add units, it's going to be the same way. So looking at this example, how many square feet would of paint would you need in order to paint this side of the house? Well, you'd have to find the area of the rectangle and add it to the area of the triangle. In this case, the area of the triangle is base times height divided by 2, 72 square feet. The rectangle is 160. When you multiply 16 times 10, the base times the height, add these two together, and what do you get? 232 square feet. And you would do the same thing for this example. You would go ahead and say 4 times 4 is going to be 16 square yards plus the area of the triangle. If you said 4 times 4 divided by 2 is 8, so you would just go ahead and add 16 plus 8, and you would get your answer. Alright, let's go ahead and talk about trapezoids. Trapezoids, they look a little different. Here's an example of a trapezoid. But if you notice, a trapezoid is just a quadrilateral. And if you cut a quadrilateral in half, and from diagonal to diagonal, you get two triangles. And you get something kind of interesting. You actually get a formula that you can use. It's kind of a weird formula. And here it's found on page 509 in your book. They kind of show you how they derive this. And they said the area of a trapezoid is this guy. Now here is a slightly different way to write that same exact formula. One that I probably prefer it this way because, like I said earlier, I love cross-canceling. So here we have the area of a trapezoid is going to be the height times the sum of the bases divided by 2. Now for this example right here, notice that I have two different trapezoids. Alright, slightly different, just kind of rotated differently. It doesn't matter if the bases are on top or bottom, or the bases are on left or right. Remember, by definition, a trapezoid is going to be a four-sided figure that has one set of parallel lines, and the parallel lines will always be the bases. In this case, the parallel lines will always be the bases, and the height is always going to be the perpendicular line between those two bases. Notice this line is perpendicular and this guy is slanted. So this guy is going to be the height. Same thing for this one. I have the two bases on the left and right, and the height is going to be the one in between them. If you look at this example, you can tell that these two lines, base 1 and base 2, are parallel, and the height is actually going to be the altitude between those two lines. Right? Because trapezoids, they don't have to always be in line with each other. They can actually have two slants on both sides. All right, so let's go ahead and look at one more example to go over today for this last lesson. All right, here this is standards check number 3, where I have a trapezoid that has two bases and one height. So I'm going to go ahead and plug these values in. All right, my height is going to be 12 millimeters, so I put 12 where the height should be. And I have 24 and 33. So it's equal to 12 times order of operations, says I have to add these first. 24 plus 33 is going to be 57 divided by 2, cross cancel. I end up getting a 1 and a 6. So with a calculator out, I can say 6 times 57 is 342. 342. And our units would be millimeters squared. 342 millimeters squared. All right, that's it. Just a reminder for us, we talked about the area of a triangle is base times height divided by 2. That's the area of a triangle. And now we have a second new formula. The height times the sum of the bases divided by 2 is the area of a trapezoid. All right, go do your homework. See ya.